Okay, let us proceed now to our next topic, in which we will be talking about geometric series. Now, geometric series is, by definition, refers to the sum of the terms of our geometric sequence. So, example there is 7, 14, 28, 56, and 112. Then, if you are asked to solve for the sum of the terms of our geometric sequence, that would add up to 217. Now, if you're going to add 1, 2, 3, 4, 5 terms, that would be easier if we're going to do it mentally or evaluatively, and we will have to come up with 217. But how about if we're going to add 20 terms? So that is why we have here our formula. This is the first formula, and this is our second formula, where these are the definitions of the variables that we can see in our formula. So S sub n is equals to a sub 1 times 1 minus r raised to n all over 1 minus r. Number 2, S sub n is equals to a sub 1 minus r times a sub n 1 minus r, and this is the same that r is not equal to 1, because if r is equals to 1, 1 minus 1 is 0, and that would be undefined. So S sub n here is the sum of the first n terms, a sub 1 is the first term, n is the number of terms, r is common ratio, a sub n is the last term. So let us try to solve for our number 1. Number 1's problem is find the sum of the first 10 terms of the geometric sequence. 3, negative 6, 12, negative 24. So we're going to use here and identify first that we have n is equals to 10, or a sub 1 is 3, and the common ratio can be solved by dividing our second term by our first term, and that is negative 2. So with this given information, we're not going to use our first formula. S sub n is equals to a sub 1, 1 minus r raised to n all over 1 minus r. So our a sub 1 is given, that is 3. So this is now the sum of 10 terms times 1 minus the common ratio is negative 2 raised to our n, which is 10 all over 1 minus r. Okay? Then let us simplify our negative 2 raised to 10, raised to negative 2 multiplied by itself 10 times. So that would answer to, okay, this is negative raised to an even exponent. That would be positive. And we will still have our operation negative, and this is equal to 1 minus 1024 all over our r is negative 2. 1 minus negative 2 will become 1 plus 2. Then let us simplify. Okay? So this is 3 times 1 minus 1024 is negative 1023 all over 1 plus 2 is 3. Okay? Then this will become 3 times negative 1023 all over 3. And this will be cancelled out, so therefore what is left is negative 1023, and this is the sum of 10 terms is negative 1023. So that is how we're going to solve using our formulas. Okay? How about if we have this one? So for our second example, our a sub 1 is 1/2, our r is 5, and our n is 6. What is the sum of our geometric sequence? So r and n is still, we're going to use our first formula. A sub n is equals to a sub 1, 1 minus r raised to n all over 1 minus r. So just simplify, substitute. This becomes 1 half times 1 minus r is 5 n raised to 6 and 1 minus r. So what is 5 raised to 6? Okay, so what is 5 raised to 6? Okay, 5 raised to 6 is 15,625. So let us double check. Okay, so we have 15,625. So this is equals to 1 half 1 minus 15,625 all over our r is 5. So 1 minus 5 is negative 4. So then subtract this one. This is 1 half times negative 15,624 all over negative 4. Okay? So next is we're going to divide this one by 2. So what is half of this? What is half of 15,624? So the answer there is 7,812. So that is equal to negative 7,812 all over negative 4. Okay, then negative will be cancelled out. And finally, we will have to divide 7,812 all over 4. So divide 7,812 all over 4. And the answer is, okay, the answer is 1,953. So therefore, the sum of our 6 terms is 1,953. So as simple as that. Since you have your calculators with you, you can use calculator to simplify since this is very large numbers. So that is a first type of a geometric sum or geometric series, and that these types here is called actually the finite geometric series. When we talk about finite, terms there, or the last term is identified already. Okay, it is identified. So let us now go to the second type of geometric sum or geometric series, the infinite. So this is the second type of geometric series or finding for the sum, and this is the infinite. Now how about if you're asked to solve for 1 half plus 1/4 plus 1/8 plus 1 over 16, and we have ellipses there, so it means that we have infinite numbers of fractions right after 1 over 16. So that would add up actually to 2. So I have there an illustration. So that illustration there is, you can see that the whole number 1 is divided by 2. Half of that is 1 half. Half of 1 half is 1/4. Half of 1/4 is 1/8. Half of 1/8 is 1 over 16. Likewise with half of 1 over 16 is 1 over 32. So what does this mean to us? So the formula for infinite geometric sequence is equal, or the formula is sum of infinity is equals to a sub 1 over 1 minus r. So by definition there, or by definition, is the sum of infinity. A sub 1 is the first term, r is the common ratio. But we will have to remember that the common ratio there is negative 1 is less than r is less than 1. Therefore, the common ratio is less than 1 but greater than negative 1. So that is our common ratio. So that is one thing that we will have to remember if we are going to solve for the infinite geometric sequence. So say for example, if I have here number 1, find the sum of the terms 3, 1, 1/3, and so on. So what is the sum of our infinite geometric sequence? 3, 1, and 1/3. So we're going to use our formula. The sum of our infinity is equals to a sub 1 over 1 minus r. So our a sub 1 is 3. 1 minus the common ratio, r is equals to a sub 2 over a sub 1. A sub 2 is 1. A sub 1 is 3. Therefore, our common ratio is 1/3. So this is minus 1/3. So this becomes, let's simplify, 3 over 1 minus 1/3. So it is safe to say that we will have to rewrite 1 the same with our fraction 1/3 denominator. So this is 3 over 3 minus 1/3. So this is 3 over 3 over 3 minus 1/3. So this is 2/3. So dividing fractions. So this becomes is equals to 3 times the reciprocal of 2 over 3 is 3 halves. And just multiply this one and the answer is 9 over 2. So therefore, the sum of infinity of this one is equals to 9 over 2. How about this one? Let us try to solve this one if we can get 2. So what is the sum of 1, 1/2, 1/4, 1/8, and so on? So we can include 1 over 16. So the sum of infinity is equals to a sub 1 over 1 minus r. So our a sub 1 is 1. 1 minus our r is a sub 2 over our a sub 1. So a sub 2 is 1/2 over 1. Okay? Then this becomes 1/2 times 1 over 1. And this is still 1/2. Okay? Then what is 1 over 1 minus 1/2? So this is 1 over 2 over 2 minus 1/2. So this is 1 over 1/2. And just find the reciprocal. So this is 1 times what is the reciprocal of 1 over 2 is 2 over 1. So this is equals to 2. So therefore, the sum of infinity is truly 2. Okay? So that is our geometric series in which we have two kinds. The first is the finite and the last one is the infinite. So if you have questions, just leave comments there. And shout out to my students in section Mahogany, Acacia, and Mulave. Grade 10. So tanang grade 10 din ha. Thank you for watching these videos and I hope you learned something out of the supplemental videos. God bless.